Welcome back to One Day Math. This is part 4. Look at the lesson card titled Combinations or Betty Goes to Europe. Remember, Betty's husband Bob is going with her to Europe. Look at the second grid to see what Bob is packing. For Bob, a complete outfit includes 1 jacket, 1 shirt, 1 tie, 1 pair of pants, and 1 pair of shoes. That's 5 categories, each with a different number of possibilities. How will you calculate the number of combinations that Bob can make? Find the number of combinations, drawing a picture or writing neatly on your scratch paper. Come back when you are ready for the answer. Remember that each change, no matter how small, counts as a different outfit. So we need to multiply all the possible choices together. 2 times 6 is 12. 12 times 4 is 48. 48 times 3 is 144. 144 times 2 is 288. So Bob can wear 144 outfits with 1 pair of shoes, and the same 144 outfits with the other pair, for a total of 288 combinations. Betty and Bob find a fabulous ice cream shop one evening. Because they are on vacation, they decide to splurge. Bob knows exactly what he wants because he always gets exactly the same thing, a single scoop of chocolate ice cream in a sugar cone. But Betty takes forever to decide. Look at the grid showing the ingredients for Betty's dessert, a double-decker ice cream cone with syrup and a topping. Betty is boggled by all the combinations she can make. Using only one choice from each of the 5 categories for each combination, how many combinations are possible? You can draw a picture or set up a math problem on your scratch paper to find the total number of combinations. Take your time and remember my 3 big rules. Stay calm, work neatly, answer the right question. Pause until you are ready to check your answer. Betty gets 2 scoops of ice cream. They could be the same flavor or different flavors. 8 times 8 equals 64 combinations. Now multiply 64 by the 2 types of cones. 64 times 2 equals 102 equals. Multiply that by 3 kinds of syrup. 128 times 3 is 384. Multiply that by 6 choices of topping. 384 times 6 gives her 2,304 combinations. No wonder Betty takes so long to decide what she wants. As you might imagine, Bob sometimes gets tired of waiting for Betty to make up her mind. That's why they have a system for making quick decisions. Every time Betty and Bob need a quick decision about where to eat or what museum to visit, they flip a coin. In a typical day of touring and sightseeing, they flip a coin 6 times. Look at the grid at the bottom of the lesson card. This grid has 2 rows. The top row will be used now for the coin toss problem, and the bottom row will be used later for a postcard problem. If the coin shows heads, they do what Betty wants. If the coin shows tails, they do what Bob wants. Theoretically, Betty should get her way exactly half the time. But in reality, there are many possible combinations. Here are 2 of the possible combinations for one day. It could happen that Bob gets his way for the first 5 decisions, and Betty gets her way on the 6th toss. It could happen that Betty gets her way for the first 2 tosses, then Bob wins on the next 4. If a coin is tossed 6 times, what is the total number of possible combinations of heads and tails? For this problem, you don't care what the combinations are or how many times Betty will get what she wants. You only need to find out how many combinations are possible. Calculate the number of combinations and come back when you're ready to check your answer.